Hello everyone, I am back with this is my architecture video and it is about Autodesk data platform. So Autodesk, just to let you know guys, it's a software company which builds software for modeling of some construction sites and interior designing kind of things. It's pretty nice software and very well known in the industry. So let's see how they're building their pipeline and if we have some comments or no.
Hello everyone, I'm Seema. Today we have Diane from Autodesk with us. Welcome Diane.
Hi Seema, thank you. Glad to be here.
Can you tell us a little bit more about Autodesk and your use case?
Yeah, Autodesk provides design and make software to innovators for them to achieve the new possible.
Okay.
For our use case, this is our data pipeline, and we
Okay, that was super vague what Autodesk do, but cool.
have data coming into S3 in the volume of 13 terabytes daily.
Okay.
Once
Wow, 13 terabytes is a lot, but for a company like Autodesk, it's acceptable because I think so they deal with a lot of 3D data. And I don't know if she's talking about the same data, but yeah, it would make sense.
the data comes in, we trigger an event to simple notification service or SNS, which then triggers invocations to the lambdas that we have. So our lambdas do a lot of processing, cleansing, the enrichment of the data. And once those are done, it actually writes metadata into DynamoDB.
Okay, so she's saying she's able to process 13 terabytes of data only with lambdas. And then she is able to put the metadata in DynamoDB. Okay, that's interesting. I would really love to know how she is processing 13 terabytes of data with lambdas. Because there could be a possibility. Obviously, 13 terabyte is not in one file or 100 files. It would be in millions of files, or maybe thousands of files. But still, considering the fact that it could one of the files can be big, Lambda has a timeout of like 15 minutes. I don't know how she's doing it, but if she's able to do it, then that's amazing. She must be saving a lot of cost over there. And saving to DynamoDB, I mean, saving metadata back to DynamoDB doesn't make sense because like 13 terabytes of data, and I can imagine like DynamoDB has, you have to pay to DynamoDB for every read and write. That could be super expensive because you might be needing your metadata in future. So instead of putting into DynamoDB, she could have put into S3 and used, if she wanted to process the metadata, then she could have used Redshift or AWS Glue to process or EMR to process it. But let's see what she has to say.
And that metadata is actually read by Elastic Container Service or ECS in order for it to do batch processing.
Wow, why would she use ECS to do batch processing? That's strange. Whereas there's like so many tools on AWS like Glue, Athena, EMR, all those things to do batch processing. Why would she use ECS? Like she has to manage her own containers, all the images and everything. She has to do all the configurations herself. That's pretty weird. I mean, I don't understand.
Okay.
And then once ECS processing is done, it actually writes data back into S3 for our end users to be able to use that data.
Okay.
What is happening over here? I don't understand, but she's putting in DynamoDB, she's processing using ECS, and then she's putting back to S3 for the end users. So end users are not actually accessing DynamoDB, they are actually accessing S3. So that is something I really want to know, like why we are using DynamoDB. It can be super expensive.
kind of batch processing does ECS does?
Yeah, sure.
Yeah, even she wants to know like what are you doing with ECS?
So ECS is actually a async RESTful web API service, and what it does is that it batches all together the output JSONs from the Lambda into batch Parquet format for read efficiency.
Oh, you can do easily Parquet with AWS Glue, and you can trigger it whenever you want. But I don't understand why ECS.
Okay, sure. And how about SNS? So, are there any other functionalities that you're trying to achieve?
Yeah, for SNS actually, we use it in two ways. One is this notification, and the other way is these lambdas, right? They actually have an internal retry mechanism,
Okay.
and once that retry mechanism, if the processing still fails, we actually send an event to SNS, which then triggers another lambda to copy that erroneous file back into S3 for us to investigate what's going on with that file.
Okay.
That's pretty nice. That's intelligent. She definitely knows how to use SNS and Lambda at least.
So, your data volume is always 13 terabyte?
That's an interesting question. The data volume, it doesn't come in into a stream like this. It actually has peaks and troughs like that. So
Okay.
at one point in time, it can be as low as 1 terabyte, and at its peak, it can actually go up to 13 terabytes. In fact, one of the challenges that we were trying to solve with this serverless architecture is because of this. In our traditional Spark-based processing, in order for us to be able to process the peak data volume, we have to provision memory in order to be able to handle this. But
That makes sense. That what she's trying to say in her Spark cluster. Let's suppose, yeah, she has taken EMR and she's using Spark. Then for 13 terabytes, she has to provision some more memory to process 13 terabytes of data. And when it's 1 terabyte, she's saying that it's it's not cost effective. So what she can do is she can actually use AWS Glue to do all this processing, and AWS Glue is serverless, and it actually runs. You can actually run Spark scripts into it because it is actually running Spark under the hood, and there's so many cool features in Glue. It gives you a visual representation how the processing is happening, and all those things. It's just like it's kind of like Airflow, but it is more integrated with big data processing instead of DAGs in Airflow. So let's see what she has to say.
in cases where the data volume is at its low, it becomes very inefficient and very costly. That's first. And the second one actually is that as the data volume increases, this is the data volume right now, but it
Okay.
keeps growing and growing. So our Spark-based data pipelines are starting to struggle in processing that data. So the data processing becomes longer and longer, and our users have to end up waiting a longer time before data becomes available. Whereas with this new event-based architecture, data actually is provided to our users in near real time at a fraction of the cost.
Okay, sure. And so, what are some of the challenges or learnings that you will have from this architecture, and you can share with us?
Sure. This is actually an interesting use case to be using Lambda for such a huge amount of data volume.
Yeah, that's what I was talking about.
As with Lambda, it is not traditionally used for big data processing like this. But since it's an interesting use case, we just have to be mindful and smart about how we're using Lambda, and the application code that we have should be very efficient in processing such huge amounts of data volume. That's the first one. And the second challenge actually that we met, this is not the original architecture. Initially, we were using S3 to read and write the metadata. However, when we were doing that, we found that the lambdas were taking around 15 minutes to process and oftentimes timing out. And when we dug,
But she just said that she's using ECS to. I mean, she's getting metadata from DynamoDB, and now she's saying Lambda is getting metadata from S3. I mean, I'm kind of confused. I don't know.
deeper, we found out that it was because of S3 is not a service that is catered to low latency, high throughput operations. So we actually did some research and found that we had to replace it with a service that is fit for that purpose, which is DynamoDB. DynamoDB is a service that handles throughput and latency very well. And once we replaced that service, we actually bring down our processing time from 15 minutes down to 20 seconds.
Okay.
Oh wow, 15 minutes to 20 seconds. That's amazing. I mean, definitely that's pretty good. But again, use glue, it's gonna solve so much of your problem. Trust me.
Are there any enhancements that you're planning for the architecture?
Yeah, one enhancement is actually this. Right now, we plan to use managed SQS for better efficiency in handling the data and handling the notifications. That's one of the key changes to the architecture that we want to make in the real near future.
Okay, awesome.
She pointed out on ECS, then she start talking about SQS and SNS. SQS and SNS is actually message brokers kind of thing, and ECS is processing compute. I don't understand the logic between it, but I'm actually confused in this video a lot, like why and why it's happening, and like literally why you're doing it and what you're talking about in few cases.
So I enjoyed this.
I enjoyed it too, ma'am. I literally enjoyed this one too. I guess you guys enjoyed it too. If you enjoyed it and if you have comments like, was I wrong when I was talking about some of the ideas or what she's trying to say, maybe I'm not able to understand. So give me a comment. And if you like the video, then give me a thumbs up to subscribe my channel. Really motivates me to make new content for you guys. See you guys in next video.